Distance time graphs are pretty cool for seeing how far an object has traveled over a certain period. Let's say this graph shows a cyclist journey. It's not just about the total distance covered over a specific time interval, like 50 meters in 9 seconds, but also about understanding different parts of the journey. So here's the cool thing about distance time graphs. The gradient of the line tells us the object's speed at any point. It's pretty straightforward, right? The gradient is just the change in distance divided by the change in time, which is basically the formula for speed. So always keep in mind that in distance time graph, the gradient is always equal to speed. Let's break it down. Check out this part of the graph, where the cyclist covers 20 meters in 2 seconds. To find the speed, we calculate the gradient, which is 20 divided by 2, giving us 10 meters per second. Since the line is straight, we know the speed is constant. When the line is flat, it means the cyclist is stationary or not moving. The gradient and the speed are both 0. Now notice this section, how the line gets steeper as it curves up. It means the speed is increasing, which is acceleration. On the other hand, when the line curves down and gets less steep, the speed is decreasing, and that's deceleration. When the speed is constantly changing, like in these last two sections, finding the speed at a specific point gets a bit more complicated. We can't just use the total distance in time like we did earlier. Instead, if we want to find speed at, let's say, 7.5 seconds, we need to draw a tangent line to the curve at that exact point and calculate its gradient to get the speed. Once as we have drawn this tangent line, we pick 2 points on it like these two and divide the change in distance, which is around 15 meters, by change in time, which is 1.5 seconds. That gives us a speed of 10 meters per second. So to sum it up, straight lines on a distance time graph means constant speed. Flat lines mean the object isn't moving. And curved lines mean the speed is changing. If the point is on a straight line, you can calculate the speed by finding the gradient of the line. Just divide the change in distance by change in time. But if the point is on a curve, you'll need to draw a tangent line at that point and calculate the gradient of the tangent to find the speed. And that's a wrap. We have covered the basics of distance time graphs, from constant speed to acceleration and deceleration. Now you know how to interpret these graphs and calculate speed at any point. Thanks for watching, and I'll catch you in the next video.